Hello, my name is Hemel Selvi, and I'm on a group with David Lee Galloway and Zane Perkins, and I'm here to discuss our semester project for computer architecture. And so, I'll go through the functions of the program as I execute the program. So I'll just start by executing the program. Alright, so the program just played its load music and its powering music. So it played the power music when it first launches, and it plays load music every time it generates a line for a card. And so the cards are generated. There's six cards: the one card, the two card, the four card, the eight card, the 16 card, and the 32 card. And basically, a number gets on the card if, when the number is represented in six-digit binary, the respective bit is activated for that number. So I'm going to begin with talking about how we generate these cards. We have a loop that runs from 0 to 63. And then it takes the largest one of these numbers. So let's say for the number 33, that's 32, right? So it subtracts 32 from 33, puts 33 in the 33 card. Then it takes that one remainder, and it takes the largest card that it can subtract from that, which is 1. And it subtracts 1 from it. Then it'll move the add the initial 33 to the 1 card. And this process is similar for every single number. And by reducing and adding it to the card, card equivalent to the number that was reduced from it, the number will eventually hit 0. So the cards it is in will, when summed up, will add to the number. And so then the next thing we have is that the cards are shuffled at the start of the program. So they're represented in an array using the numbers 1 through 6. And the array is shuffled using Durston-Fields shuffle, which is basically you take the last element of the array, randomly swap it with another element in the array, including itself. Then you make the array 5 elements instead of 6, so you take the last one out. You take the last element of this subarray, swap it with a random one, including itself, and you do this until you have a subarray size 1. And so now that we've run through card generation and card shuffling, I'll go through a sample program execution. So in this case, we're going to try to hit 44. So 44 does appear on the 4 card. So in this program, usually when requested to type in yes, you type in 1. When requested to type in no, you type in 0. So since it appears in the 4 card, I'm typing in 1. Alright, so now in the 8 card, it also appears. So once again, that's a 1. This is the 16 card. 44 does not appear in the 16 card, so that's a 0. 32 card. 44 does appear in the 32 card, so that's a 1. Alright, and then for the 2 card, there is no 44, so that's a 0. And then for the 1 card, there is no 44, so that's a 0. And so that is the game over music. And the program calculates the number by taking it stores the total value in memory, initialized at 0. And as you go through the program, it will take the first value of the card if you typed in yes or 1, and it'll add that to the total. So you'll end up getting the sum of the cards that the number appears in, which should add up to the number itself. And so I'll do one more sample run just so we can repeat the process, this time not explaining every individual step. Here, I'll make this one easier to view. And so we're going to go with 63 this time. 63 obviously appears in every card, so it's just 111, 111. Alright, and then I will terminate the program here. And that is the termination sound. So any further steps that weren't covered in here, like card display, which basically just uses a bunch of loops to generate each card using the address of the first value in the array, will be covered in the project write-ups. Thank you for your time, and I hope you enjoy the project.